Welcome everyone, hope all of you are doing very well. Today I am going to discuss about how to design primers using Primer Blast in NCBI. For that, first of all, go to Google and search for NCBI. Entering NCBI, search here in this section for genes and type your required gene name in this section. For me, I am going to design primers for some exonic regions of EPHX1 gene. I am searching for EPHX1 gene and click search. Now, they will show the results. See, the first result will show you it for Homo sapiens or human. I am going to design primers for the EPHX1 gene of human. For that, I am clicking on this side, EPHX1. Here you can see the location of your gene on chromosome 1. Click on this link of EPHX1 of Homo sapiens and they will lead to a new page where you can get all the basic information regarding its function and all the things. Just scroll down and you can see the number of exons in this gene, that is 11. Here you can see the graphical representation of overall chromosome 1. And where does your gene decide? This is where my gene, the EHX1, is located on the chromosome 1. Now if you scroll down more, you will get the more detailed graphical representation of your gene. This is the EPHX1 gene, and if you just put your cursor on it for some time, they will give all the basic information regarding this gene. Now, as you all know, a gene has exonic part and intronic part. Now, what are the exonic parts? These green blocks are the exonic parts, whereas these green thin lines is the intronic part. Now, let's say you want to amplify this exon, the second exon of your EPHX1 gene. So for that, just go to this part and select some region, drag some region around your second exon and click on Zoom on Range. I am clicking on Zoom on Range. They have now zoomed your second exon of EPHX1 gene so that you can design your primer very easily. As we all know, for PCR, we need two types of primers. One is forward primer and another one is reverse primer. For designing forward primers, select some regions before starting of the exon, just this region, and do keep some gaps between your required primer sequence and your exonic part or gene sequence. Now I am selecting this region. Now press Ctrl and now select some region for designing your reverse primer. I am selecting this region for reverse primer sequencing. Now click on here and now just keep your cursor on this range and select for Primer Blast. Now whenever you will select Primer Blast, they will lead to a new page where you can get the accession number of your EPHX1 gene and the forward and reverse primer range that you have selected and all the default details, information regarding primer parameter, exon intronic selection, primer pair specificity checking parameters, etc. here. You can change it, but I generally keep it as default. But if you want, you can change it. For example, see here, they have given that the maximum PCR product size will be 316 and minimum is 70. If you want to get your minimum number increased, you can just change here. You can change all these parameters accordingly if you want. You can also change advanced parameters, but I am not changing anything. I am just clicking right to the Get Primers. When you will select Get Primers, they will open a new window and they will design primers for you. And generally, the first one is suitable, but this process will take some time, like 4 to 5 minutes. After that, we will see all the primers that the Primer Blast have designed. NCBI have designed for you. Let's see how much time does it take. Now they have given you the results. Here you will get the graphical view of your primer pairs. The details will be shown. They have designed 10 primers for you. And generally, the first one is the most useful one. Okay, generally we select the first one, but let's see. These are the 10 pairs of primers that they have designed for you. In each pair, you will get the sequence of forward primer, then the sequence of reverse primer. Then obviously, the forward primer is plus strand, and the reverse one is minus strand. The length of both the primers, 20, 22, you can see the starting position of the primer from 744 to 763 like that, and stop position. Now this is the important position, TEM, the melting temperature. You can see the melting temperature for primer 1 is 60.84 and for reverse primer is 59.77. Just average these two and you will get your PCR melting temperature, okay? The aniline temperature, Then the GC content. As we all know, the GC content between 40-60 is a good indicator of any primer because as much as your GC content, that means the primer anneal will be more stable. As we all know, GC bond is more stable than AT bond. Now the self-complementary, it should be between 4 to 6. Self-complementary means how much your primers can complement with each other. That means how much is the probability of forming primer, dimer. If it is low, it is great, and if it is higher, it is not so great. Now going to the self-3', 3'd complementarity, it means the 3', 3' part of your forward primer is a forming dimer with the reverse primer or not. What is their complementarity? Or the 3' part of your forward primer is forming dimer with itself or not, or same for the reverse primer. So seeing all these information, you have to choose the correct primer for your PCR. And in my next video, we will see how to check PCR in silico, PCR primers, amplification in silico. For today, I hope this video will be useful for you. If you find this video useful, don't forget to hit the like button and share it with your friends. For more such videos, don't forget to subscribe to my channel. Thanks for watching.